If you worked in artificial intelligence in the 80s, there was like a massive round of popularity, and we're sort of seeing that again. What's fascinating, I think now, sort of contextualize it, why have another AI conference now, is really the popularity of it, but also how ubiquitous computing is now. We all have smartphones. Our laptops and GPUs can do things that they couldn't do before. So we're actually in, I think, a really fantastic time for there to be more creators getting involved with something like artificial intelligence. There used to be, I think, so many barriers to entry when it came to engaging with something like AI just based off the technical prowess needed to engage with it. But now, artificial intelligence and machine learning, they're used in almost every aspect of our lives. Probably from a more, like in the background to something even in the forefront. It's a little early, and I haven't had enough coffee. But yeah, so one of the things we were thinking about is what's on the next horizon when it comes to artificial intelligence, and I think a lot of that is contextualizing it within art and activism. And that was one of the reasons we decided to really focus on that as a cohesive theme. I started FACETS a few years ago with Jane Friedhoff, Mohini Dutta, and Phoenix Perry, and Nadell Lin, and we were really interested in trying to create an unconference. So how do you take something that has a conference setting but feels more like a zine instead of having it feel like a highly published book? So this is a laid-back environment. We encourage dialogue, we encourage questions. In between breaks, feel free to talk to the speakers. They are not here to exist away from you, but with us, this is a place of dialogue. Because of that, I want to talk about our code of conduct. So we have one. It is on our website. Feel free to read it. I love codes of conduct. I think they're great. I think it's important for all of us to be respectful to each other. Our code of conduct is one that we've designed with the Code Liberation Foundation, which is a nonprofit to get women and non-gender binary people into gaming, into making games. It also is inspired by the Geek Girls Code of Conduct. Some just basic housekeeping tips. Be respectful. Understand that some people may not want to talk to you in a conversation. If they walk away, let them walk away. We have a zero tolerance policy towards harassment. Do not engage in misogynistic, racist, or homophobic language. Don't do it. It's not funny. We will remove you. But feel free to ask questions, but try to be respectful of your space and the distance between you and others. If you have a question about how to engage with someone, feel free to come up and talk to me, and I can try to help you troubleshoot how to ask a question if you have any questions about how to engage. If you feel like if you've had an uncomfortable experience, please come up to me or any one of the organizers, Tamiko or Sarah, when we can help you as best we can. Also to note, our hashtag is FACETS17. Feel free to tweet if you want to. We have Wi-Fi information up, and we've also printed out the code of conduct if you want to look it over. So with that, I'm really excited to start FACETS. Tamiko?
Can we drop the lights a little bit so these slides are a little bit more? Okay, let's see. Okay, oh great, fantastic. Don't go to sleep now. So thank you very much, Sarah and the Goethe Institute, for hosting us here. We were really excited when we could engage them to hopefully get to a different part of the audience, since Carolyn and I tend to sit fairly deeply in the media art circles. And as Carolyn had expressed, we started talking about this idea about a year ago. I am not an AI researcher. I started out as a mechanical engineering product designer, and then when I was a grad student at MIT in mechanical engineering, was hanging out in the AI lab because they had the best parties, frankly. And my friend Danny Hillis, when I graduated, happened to be starting a company, Thinking Machines, to build this new type of computer. He asked me to do the product design. I am delighted to say I got one of them saved into the MoMA Permanent Collection. It's in an exhibit that's opening on the 13th. And that led me to the question, well, what's happened to AI over the last 30 years? Because back then, when Danny came up with this idea of creating a new type of computer model on the human brain, on the idea that the processes are not important, it's the connectivity between processors that are important. Basically, the whole supercomputing, the big boys, the adults of the supercomputing industry laughed at us and said, you realize that artificial intelligence is a bunch of bunk and it'll never work. So, of course, when, in the last 5 years or so, as AI has suddenly started taking over the world, so to speak, I was really curious what happened in that time, and it turns out that Carolyn knows everybody doing interesting work on this sort of social aspects of AI. So we said, let's do this conference. And just really quick, what happened to the lights? All of a sudden, someone leaned on them, I'll bet. Thank you. Okay. So just really quickly, in case you're not all AI researchers out there, the best description of AI is everything that hasn't been done yet. That seems to be in the realm of things that animals and humans can do better than existing machines, and things that seem to require intelligence, reasoning, knowledge, planning, learning, understanding human language, but also the intentions and the context of interacting with other people or other animals, perception of images, environment, navigating through that, and being able to manipulate that. So the fear of humans taking technology and then somehow creating catastrophes has been there a very long time. Just one example from ancient Greece, where the gods Prometheus and Athena created humans. Prometheus gave them fire, i.e. technology, and was punished eternally by the head god Jupiter for doing that. But humans started making machines that were more and more precise. Clockwork mechanisms were really the machines of the Middle Ages, and here's one example of a human figure, like a robot, an automaton, that was serving drinks in the this is the realm of sort of Iraq, Syria, Turkey of these days, which was the height of the technological center then. And then as it shifted to Europe, the Europeans also started doing a lot of automatons, including ones that could do things that only a very highly educated, quote-unquote, intelligent portion of the population could do then, like writing. Not everyone could write at that point. So the philosophers of the Enlightenment, I think probably also triggered by the Christian stipulation against chopping up people and looking at their innards, sort of dissolved, and so people were saying, well, the heart is like a pump and the lungs are like billows. So this idea of the body as a mechanism, the body as a machine, and animals as machines, and the only difference between humans and machines or animals was this very abstract thing called thinking, came to be more and more prominent. And Descartes is known as the sort of the father of the mind-body split. But there were a lot of other philosophers, mathematicians, physicists who were looking at systems of thinking, systems of manipulating symbolic forms of calculation, and there was this equivalency of logic, thinking, intelligence that started coming awry when people were also building calculators that could do some of this activity. So these were mechanisms, very clear mechanisms. You could take them apart and then they would stop working, but they could do things like mathematics that you know, a lot of human beings couldn't do, uneducated human beings. So the idea of maybe a machine could be built that could meet or exceed human intelligence got more and more realistic in some sense. And then in the 19th century, Charles Babbage came up with the idea of a programmable computer, designed for a machine that was not built for a specific purpose, but could be reconfigured for different types of problems. Ada, Countess of Lovelace, came up with what's now considered to be the first programs, but this was all very theoretical because the technology of the time did not allow Babbage's designs to be built in a way that really worked. He tried many times, but it was really only 150 years later when the London Science Museum had a machine built using modern technology that could do a lot more precise gears, tolerances, etc., that they found out we built it to his design and it worked. So wars are always good for promoting technology. And in the Second World War, they were needed for calculating the ballistics of rockets, and also for breaking ciphers. So all this area around cybersecurity was really worked on by a lot of the machines that were built at that time. And also, I was surprised to find out in my research for this topic that even in 1943, there were scientists who were looking at neurons as a model for signal processing. So your neurons take in signals, process them in some way, send them out to other neurons, and McCulloch and Pitts were able to, in 1943, create a very simple circuit based on this principle. So it's a lot older than I actually expected. Very famous, and Alan Turing's Turing test in 1950, where he started out saying, let's ask the question, can machines think? And then he said, well, it's actually very hard to define what thinking is, so let's reformat that question and say, okay, if in a conversation between an interrogator and something else, the interrogator cannot tell if they're talking with a human or a machine, then that machine can be said to be intelligent. These days we would say it's more that it can be said to be believable, and we have a whole panel actually on this subject. He was prosecuted for being a homosexual and is widely regarded to have committed suicide because of that. So let's hope that some people can't turn back the clock to that era. So also, a lot earlier than I expected, Arthur Samuel created a self-learning checkers playing program. And this sort of strategic game was also always thought as a sign of intelligence. Checkers, chess, go. And back in 1956, he demonstrated a checkers program that actually was self-learning and coined the term machine learning back in 1959. So that era, the late 50s and then into the 60s was really the golden era, the first golden era of AI. And people back there, famous researchers back then, were saying, in 20 years, we will have machines that have exceeded the capacities of humans. Humans won't be needed anymore. I can download my consciousness into that machine and live forever. All the problems will be solved. And then unfortunately, 10 years later, when it didn't seem like they were making a lot of progress, all the funding that had flowed into supercomputers and AI in the aftermath of the war in the 60s and this initial wonderful progress was withdrawn fairly suddenly and created the first AI winter. But you know, even if they're cooking on a slightly smaller flame with a lot less money, researchers had continued to work on problems that they thought were interesting, and that led at the beginning of the 80s to successes in a different type of AI program, expert systems, where you had a huge, or what you thought then was a huge, database of known facts and a set of rules about how these facts could interrelate to each other, and then an inference engine that would apply these rules to the facts and reach conclusions, for instance, a medical diagnostic system. And so there was actually systems that were able to save companies a lot of money by being implemented, and so there was this idea of, well, okay, maybe types of AI really are possible, but the really big problem then was we need massive amounts of data to make this sort of expert system work. How do we get all that data into one machine? Well, the whole area of funding in the US and the UK got a big kickstart when Japan, kind of out of the blue, announced that they were funding a 5th generation AI effort. And so all of a sudden, the Defense Advanced Projects Research Administration said, okay, we better start funding it also. And that's when money started flowing back in. That's exactly the point when thinking machines was started, the connection machine was built, and this is really sort of where my involvement with the AI started. And the architecture was very specifically aimed at dealing with these amounts of big data. The gentleman sitting there on the floor with the fuzzy hair is Brewster Kahle, who created the Internet Archive and was really motivated to work on the connection machine by his dream of creating a new Library of Alexandria with access to knowledge for all around the world, and was developing technologies that made that possible. So this was a single machine with a massive number of processors all connected together that really worked well with big data in a way that the very powerful supercomputers of that time didn't. By the way, the equivalent of a CM these days is an iPhone 5. So the company went bankrupt for various reasons, including the fact that after the Cold War ended, the government cut funding to supercomputers again, and things continued as it had in the first AI winter. In the second AI winter, things continued developing, but were not called artificial intelligence because that was a sure way of not getting your funding. So this idea of, when I went back and talked to friends of mine at the company, who were at the company, and Danny, and they said, our idea of going from massively massive amounts of processors to larger and larger, where the processors are becoming more intelligent, is really realized in this evolution that we've seen towards cluster computing. Google took over a lot of the knowledge that came out of thinking machines. Sergey Brin programmed the CM2 as a student and adapted Danny's algorithm for mapping massive amounts of data on massive amounts of processors and turned it into the MapReduce algorithm using his cluster computing. And then what I hadn't realized at all was that Danny Hillis had done a subsequent company dealing with semantic networks and sold that company to Google, and his CTO became the head of Google Artificial Intelligence. So we went from supercomputers that were the first search engines to being able to, through the World Wide Web, access computers all over the world. People now have supercomputers in their back pockets, but they're not just pulling data out of that, they're also, through the Web 2.0 and the social media, they're putting a lot of data in there, and they're also ranking it, they're judging it, they're training the artificial intelligence systems that are out there at different companies. How good is this data for doing specific tasks? Every time that you use Google search and then select one of the options, it says, aha, okay, well maybe let's refine our concept of what this search term actually means. So that's where we are today. I'm really, really excited that we have so many people who are working in this area with a critical view, with a view of the cultural and the social aspects of this technology, and really delighted to be able to learn from them and from all of the people in the audience who I hope will really participate in the discussion, because this is the conference for the rest of us. This is not a bunch of technical experts talking with each other within the confines of their company. We want to start a discussion and say, how can we start participating in this discussion? Where is AI going? What's it doing? Thank you very much.
So So we're just going to have a short 5-minute break while the next panel gets set up. That is enough time to maybe grab one more snack.